Hello students, good morning. Welcome to my lecture for class 12 science subject chemistry, Maharashtra State Board new syllabus 2020. In the previous lectures we have started chapter number 8, transition and inner transition elements. In the previous lectures we have studied about oxidation state of first transition series. Today we are going to study about physical properties of first transition series. Now you know that the elements belonging to first transition series are what? You know that scandium, titanium, vanadium, chromium, manganese, Fe, cobalt, nickel, copper and zinc. Now come to the point, physical properties of first transition series. See, first you know that generally transition elements belong to d block elements and they are what? Metals. So generally they show properties of metals like they show luster, they show malleability, they show ductility, as well as they are good conductors of heat and electricity. Except these elements, all other elements of transition series show one or more typical structure. And there you know that mercury is present in the liquid state, which is used in thermometer. They show what? Shining appearance, that you know, and similar nature is also observed in zinc, cadmium and manganese. I hope you understood all these points. Now see the next point. See, all the elements belonging to transition series are hard and they have low volatility. Exceptions are zinc, cadmium and mercury. They are not hard. You know, mercury is in liquid state, zinc is what? Soft. They are not hard and they don't have low volatility. I hope you understood this first point. Now come to the next point, that is what? They show high melting point and boiling point. Now, all the elements belonging to transition series show high melting point, boiling point. High melting point and boiling point. Now come to this graph. See, this titanium, vanadium, chromium, manganese, Fe, cobalt, nickel, copper. See, these are what? See, there is atomic number and here is melting point per 10 raised to 3 Kelvin. Because you know that the melting point of titanium is nearest to 2000. So it is what? 2000, 1000, 2000, 3000, 4000. I have written here melting point per 10 raised to 3 Kelvin. Remember that it is 1000 Kelvin, it is 2000 Kelvin, it is 3000 Kelvin, it is 4000 Kelvin. Now see, for manganese, for tellurium, on y-axis melting point per 10,000 Kelvin, see it is 1000, 2000, 3000, 4000 Kelvin, and see on x-axis there is what? Atomic number. Now this element shows first transition series, this element shows second transition series, and this element shows third transition series. Now see what happens. At the initial stage, titanium, vanadium and chromium, they show increase in the melting point, but see at manganese they show what? Decrease in melting point. Here manganese, Tc and this OS, they show what? Less melting point. But here what happens? Up to manganese, melting point goes on decreasing and again they are what? Increasing up to Fe. means this Mn and Tc, they show what? They show anomalous melting point. Remember this point. They show what? Anomalous melting point. Nc, chromium in the first transition series, molybdenum in the second transition series, and tungsten in the third transition series. They show what? High melting point. High melting point. Remember that. Tungsten, molybdenum and chromium, they show what? High melting point. But Tc in the second transition series and manganese in the first transition series show anomalous melting point. Anomalous melting point means what? Their melting point always varies. And see, after that, melting point goes on what? Decreasing. As the atomic number increases, the number of unpaired electrons decreases, and therefore they show decrease in the melting point. I hope you understood this first point relating with physical properties of first transition series. Now come to trends in atomic radii. You know that atomic radii means what? See, the nucleus and outermost shell of an atom is called as atomic radius or atomic size. Now come to first transition series. You know that in this first transition series, what happens? The atomic size goes on decreasing from left to right. See here, for scandium, atomic number, that is Z, is equal to 21, and for zinc it is 30, because titanium 22, vanadium 23, 24, 25, 26, 27, 28, 29, and zinc it is what? 30. Now we will see what is the reason behind that. You know that for every element the nuclear charge increases by 1. For titanium it is increased by 1, it is 22. For vanadium it is also increased by 1, that is 23. Now come to this. This is nucleus, first shell, S subshell P, D and F. What happens here? See, it is what? It is last shell. It is penultimate shell, and it is penultimate shell. Means it is n shell, it is n minus 1, and it is n minus 2. Remember that. Last shell means what? N shell, n minus 1, n minus 2. What happens here? In d block elements, last electron enters here. That is what? In the penultimate shell. And see, these d electrons, they are what? They have less penetrating power. Due to diffuse shape of d subshell. And therefore what happens? Nuclear charge increases by 1, and every electron enters here, and this d electron show small screening effect. Screening effect already we have studied in 11th standard. So these d electrons cannot protect this electron present in the outermost shell to go towards the nucleus. They cannot shield them, or they cannot screen these last electrons from the nucleus, and therefore the effective nuclear charge increases, and due to this the size goes on decreasing. This is the reason behind that. Now see here. The elements belonging to first transition series, they have less or small atomic size as compared to the second and third transition series. See this order. The size goes on decreasing for the second and third transition series, and for the first transition series size goes on decreasing. And see, second and third, they have similar atomic size. I hope you understood this. Now come to the next point. In case of ions, the distance between center of the nucleus and outermost shell of an ion is called as what? Ionic radius, or it is also called as what? Ionic size. Now come to trends. Trends in ionic radii. We have already studied about variable oxidation state of first transition series. Now ionic radii is also related with what? Oxidation state. There are 2 points. Elements with same oxidation state. We consider, for example, divalent ions. Now see, if you consider chromium 2 plus, it has ionic size 82 picometer, and for copper 2 plus, size is what? 72 picometer. Now see, in divalent ions, as atomic number increases, effective nuclear charge is also increased, and due to that, chromium have more ionic size as compared to the copper 2 plus ion. It is because of stringing effect of n-1 d electrons, and so that this chromium 2 plus having 82 picometer size and copper 2 plus 72 picometer size. Now consider next elements with ionic radii is also studied by considering variable oxidation state of the same element. If we consider manganese 2 plus have more ionic size than manganese 3 plus, then manganese 4 plus. See what happens as the number of electrons are lost by these elements, then effective nuclear charge also increases, because effective nuclear charge is distributed in less number of electrons here, so it has less ionic size as compared to Mn2 plus. Similarly, again in Mn4 plus, 4 electrons are lost and therefore charge is 4 plus. That means here again the number of electrons are decreases, and so they get more nuclear attraction, and so they possess less ionic size as compared to Mn3 plus. So this is about what? Trends in ionic radii. I hope you understood these two properties. First melting point and other general properties, then atomic radii and this ionic radii. Now see ionization enthalpy. Ionization enthalpy is also called as ionization energy. That also we have studied in 11th standard. Ionization energy means what? Amount of energy required to remove the most loosely bound electron from an isolated gaseous atom from its outermost shell. Now it is about what? Ionization enthalpy. You know that metals, Generally metals have what? Metals have low ionization enthalpy because the tendency of metal is to lose the electrons. But you know that d block element present between S block and D block, S block and P block elements. And you know that S block elements more electropositive. And C, D block elements are less electropositive. And P block elements, they are what? More electronegative and less electropositive. And therefore D block element, the ionization enthalpy of D block elements is intermediate. Between S block and P block element. Means D block element shows intermediate ionization enthalpy because they lie between S block elements and P block elements. D block elements, they are what? Less electropositive, as less S block elements are more electropositive. And you know that S block elements having what? All the metals here, metals, but in P block elements they involve metals, non-metals and metalloids. Now come to this table. See, this titanium, vanadium, manganese, Fe, they show what? First transition series elements. These are what? First transition series elements. And see these zirconium, niobium, molybdenum, then technetium, ruthenium, rhodium, etc. They show what? See, they show second transition series. And see this one, it is what? Third transition series. Observe this figure carefully. This is the graph showing the relation between transition metals and first ionization enthalpy in kilojoule per mole. Now, what happens here? From titanium, the ionization enthalpy goes on what? Decreasing, and again it shows increase in the ionization enthalpy. Again they show what? Decrease in the ionization enthalpy. Means that is what? Variable. But see here, the first ionization enthalpy for third transition series, we can say it is shown by IE1 is what? Is more in case of third transition series as compared to the first and second transition series. What is the reason behind that? Because see, this third transition series, they contain filled 4F subshell. And there you know that these 4F electrons, they show poor shielding effect because they have diffuse shape, and therefore the nuclear charge per electron is very large, and therefore they show what? More affection towards the electrons, outermost electrons, and therefore they require more amount of energy to remove the last electron from the outermost shell, and therefore they possess more energy, and so the first ionization enthalpy of third transition series is more as compared to first and second transition series. Okay. Now see, in the first transition series, ionization enthalpy of first ionization enthalpy is less as compared to the RE2 and RE3. Means first ionization enthalpy for every element is less than that of second ionization enthalpy, which is also less than that of third ionization enthalpy, because it is very difficult to remove electrons from the stable elements or stable ion. If you consider titanium, first ionization enthalpy you get titanium plus 1, here titanium plus 2, and here titanium plus 3. It is very difficult to remove 3 electrons from titanium, and so they possess what? They require more energy to remove these electrons, and therefore they have more third ionization enthalpy. I hope you understood this concept about ionization enthalpy. One more point I have to tell here: in the lower oxidation state, in the lower oxidation state, they form ionic compounds. But in higher oxidation state, they form what? Covalent compound. Remember this. Means these d block elements can form ionic compounds in lower oxidation state, because see titanium plus 1, that is what lower, and see here titanium plus 3. So in higher oxidation state they can form covalent compounds. I hope you understood all this concept. Today we have studied about general physical properties of metals, melting point, atomic size, ionic size, and ionization enthalpy. I hope you understood this concept. Thank you very much. In the next lecture we will study remaining